So an aquifer is a layer of permeable rock through which water flows freely. The word permeable means that water can move through it. Okay, remember from our video on the Macatawa watershed, we learned about permeable and impermeable or impervious surfaces, I think the raindrop said. Impervious or impermeable means it can't go through, permeable, water goes through. So any body of rock or sediment that yields, meaning we can take out useful amounts of water, is considered an aquifer. Three things are needed for an aquifer to form, though. One, a layer of permeable material to hold the water. In this case, we have sand and gravel, very permeable. Okay, and even a fractured rock over here. It's only permeable because of all these little cracks. Two, a neighboring area of impermeable rock that keeps the water from draining away. So we have to have some impermeable layers somewhere near here to keep the water in place. Maybe that's the bedrock at the very bottom, underneath the sand or the gravel or something like that. Or maybe it's a layer of clay. That's considered impermeable too. In this case, we can see this line here. There doesn't appear to be fractures in there, but perhaps there is. So in our case, it's probably further down here, underground, because we're not really seeing any impermeable layers. That silty layer could be one, but. And lastly, a source of water to refill the aquifer. Otherwise, it's just going to get depleted if we're using it. In this case, the top surface here is all permeable. So when it rains, or the stream perhaps, it can all infiltrate down to our aquifer and recharge it. So see here the word aquifer. All this is an aquifer. So what are wells? Wells are dug to get water where natural springs don't occur. All of us in Hamilton here have a well at our house. That's how we get our water in our house. If we live, for those of us that live in Holland, we're probably on city water, and we are not just getting groundwater from a well. Once you dig your well to an aquifer, you can pump water to the surface. So we have a few wells dug here. As you look at this diagram, you see some that are very deep into this fractured rock aquifer. You see some that are awfully shallow, maybe just below the water table, right in the middle of the diagram. And then over on the left here it says drilled well into soil. Pretty safe aquifer down deep here. In general, the deeper you are, the better off you are, because one, water has been filtered as it has moved down through there to get to your well, and it is relatively safe from any pollutants that are coming from the surface. Like a leaking gas tank, or maybe there was an oil spill on the surface, or in a body of water right here, a stream, something like that. So we're going to be taking a look at wells, what types of wells are the safest, what could be the most polluted, and things like that. An artesian well is a well drilled into an aquifer where it's under pressure. So I can see the water table up here, and somewhere upstream it's being recharged from the surface, but it's between two confining layers, impermeable rock above and below. And so what makes this happen is, once we dig into that, it's under pressure, gravity here, pushing this down, and so water will just come out. We don't even have to pump it out. Okay, so we could put a cap on that. We wouldn't need a pump. We could just have a faucet and turn the faucet on when we want water. It would come on out. So a few things here. Recharge from precipitation. Over on this side, I want you to, if these arrows are not in, put them in and go ahead and label these diagrams. We have recharge from precipitation, recharge from a surface water body right here. Let me see the water table, of course. the unsaturated zone, and the saturated zone. Okay, which remember is the groundwater zone. Now in this diagram, we have an island here, and a couple interesting things. One interesting thing is, saltwater intrusion here. If this well over pumps, it's going to suck this salt water in. That would be bad. But also, we have groundwater discharge to a surface water body because this spring here, excuse me, the spring is at the water table. Okay, so the water table, the groundwater is giving to the surface. Alright, you guys, I'm going to wrap this up pretty quick here. I realize this set of notes is getting sort of lengthy. So, looking at this concept here, we're talking about groundwater contamination and the importance of well siting. Again, make sure you're drawing in all these arrows and all of the notes I'm putting on here. So this well's over here, on the system over here, but the contaminants are moving this way. And in this particular instance, possibly getting sucked into this person's well. Okay, again, use that pause button if you need to. I'm going to try to pick it up here a little bit. Okay, so here's this diagram again. On the top here, we have sustainable yield from an aquifer. That means it is sustaining. It's going to keep on going. We're not taking out more than is going in. On the bottom, impact to a surface water body from a well. We overpumped our well, and whoops, we dried up the home here for the fish. I feel bad, but oops. Porosity, percentage of space in rock and soil that contain water. So in this particular diagram, we're saying low porosity because there doesn't appear to be a lot of spaces in there to hold water. And in the bottom, high porosity because there's lots of open spaces to hold water. Permeability is the ability or capacity of water to flow through rock or a particular type of sediment, gravel, sand, something like that. Water can flow readily or easily through rocks with high permeability values. So permeability is greater, it says, through this passage on the right. Note this bigger open space here than this one on the left. So obviously more water can get through this side faster, so it has a higher permeability value. Okay, but again, permeability is the ability or capacity for water to flow through a particular sediment or material. With that said, you guys, these notes are done. We'll move on to term notes.